G'day chemistry students, in this video we are going to be looking at dot point 7.5.3. We're going to be introducing a new kind of organic chemical known as an ester. In this video in particular, we're going to be focusing on naming rules as well as its structure, and then starting to look a little bit into its properties and some relevant reactions. Let's get into it. So first off, for our structure of an ester, what we should notice is that it's really similar to a carboxylic acid. We have a carbon that is double bonded to an oxygen that also has a single bond to a second oxygen. Now the difference here is that instead of there being a hydrogen bonded to the single bonded oxygen forming a hydroxyl group, we actually have OR-, meaning that there is an alkyl group bonded to this oxygen. What this also means is that this carbon here will never be the terminal carbon, the carbon that is at the end of the chain. We already know that carboxylic acids can only be at the end of a carbon chain. Here we have a very similar carbon oxygen group, so one carbon, two oxygens, but in this case we find that the group is somewhere in the middle of the chain. There is an alkyl group R and an alkyl group R-. So when naming an ester, the first thing that we need to identify is the alkyl group here is always R-, so that's a methyl ethyl propyl group, and that group is always attached to the oxygen, where there would usually be a hydroxyl group for a carboxylic acid. The main chain is always R, and R is always attached to the carbon, which is a part of our ester functional group. Now, when naming, what we do first is identify the alkyl group, use our chain length prefixes to figure out the name for the chain that's attached to the oxygen. Then for the main chain, we use our chain length prefixes and a suffix -. So in our first example here, we can see that the alkyl group has 1, 2, 3, 4 carbons, meaning that we start with the term butyl. We then have a main chain that is 2 carbons long, therefore that is referred to as ethanoate. So eth for the 2 carbons, and because there are single bonds, -ate as our suffix to say that we have an ester functional group which is present. In our second example here, first thing again that we need to do is identify the alkyl group. The alkyl group is attached to the oxygen and there are 2 carbons. That means that the first term that we'll be using is ethyl. The main chain is on the left. It has 1, 2, 3, 4, 5, 6, 7, and 8 carbons here. So the term for the main chain is octanoate. What I want to identify as well is it doesn't matter what the chain length of either chain is. The main chain is always attached to the carbon in the functional group, and the alkyl chain is always attached to the oxygen that is in the functional group. When looking at properties of esters, what we need to be considering is 2 core things. We have big non-polar chains on either side of a functional group which has some weak dipoles. We have a dipole with our C double bond O, our carbonyl group, as well as our C single bond O. Both of those are weak dipoles. They will have some degree of polarity in some ways, but a lot of the time our esters have these big, long, non-polar chains. Now, what this means is that most of the time the non-polar bonds dominate, but our ester will be slightly more polar than, say, an alkane, alkene, or an alkyne of a similar mass or chain length. However, in comparison to a lot of the polar substances that we've looked at already, the strength of the esters' polar bonds is generally not as strong as most other examples that we have looked at, and that does reflect in its resultant properties, particularly with solubility as well as boiling point. But we can have a look at some of those in class. Now, the main reaction that we're going to be looking at within the scope of this course, which is related to ester, is the production of esters itself. You may see the term to describe that as esterification. So when we are producing an ester, we always have an alcohol and we always have a carboxylic acid. Essentially, what can happen between the two of these is that the 2 hydroxyl groups are able to interact. Both of the hydrogens leave the 2 compounds as well as one of the oxygens. What we're left with is a bond between the 2 alcohol and carboxylic acids being attached with an oxygen. The 2 hydrogens and oxygen that left form water as a byproduct, And what we end up with is essentially an ester. The carboxylic acid has still its main chain as well as its carbonyl group. The alcohol has its main chain as well as the oxygen, which was a part of the alcohol, meaning that in the center, we end up having our ester group forming. So keeping in track with our naming rules, what we should be able to observe is that the alkyl group that's being named first in an ester always originates from the alcohol reagent that produced it, and the main chain, which has the suffix O8, always originates from the original carboxylic acid which made it. What we see here is a chart that begins to outline a bunch of different combinations of esters. So esters can be produced by a variety of alcohols and a variety of carboxylic acids. And depending on what alcohol and what carboxylic acid you use, will dictate essentially the length of both the main chain as well as the alkyl chain. And a very interesting property of esters is that they have quite unique tastes and smells in particular. And the combination of main and alkyl group chains will lead to a variety of different smells and tastes, many of which are associated with a variety of fruits, especially some of our lower mass esters. Once we get into some of our higher mass esters over here, the variety of smells and flavors really does begin to diversify. Thank you very much, everyone. In the next video, I'm going to be going over a bunch of strategies and equipment setups for an experiment that we will undertake to prepare an ester ourselves. Essentially, I'm going to be giving you a variety of different carboxylic acids and alcohols. You're going to be able to select a combination of those and make an ester yourself. But until then, have a good one.